Module 5, the muscular system, histology and physiology. Multiple motor unit summation. An entire muscle consists of lots of muscle fibers, and they can be grouped into many motor units, or just a few. That means that some muscles are controlled by a few motor neurons, while others are controlled by lots of motor neurons. Now, when each muscle fiber contracts, it's completely contracting once it receives an action potential. So it's all or nothing. It either fully contracts or not at all. And that's for each specific muscle fiber. Scientists call this the all or none law of skeletal muscle contraction, which states that an individual muscle fiber contracts maximally in response to an action potential. Now think about motor units. One motor neuron sends an action potential to all the muscle fibers it innervates. So when a neuron sends a signal, all the muscle fibers in that motor unit contract the same with each action potential sent. Well, think about when you try to flex your biceps muscle. Let's say you want to pick up a feather. You can feel that your muscle contracts a little in order to lift your forearm upwards. But now imagine you want to lift a bowling ball. You know you can feel your muscle working harder, bulging more. So how come your muscle doesn't completely contract all of its fibers or none of them? Well, your whole muscle can partially or completely contract because it is made up of several motor units. So, though each motor unit contracts in unison, like the all or none law states, your muscle can contract different amounts of its motor units depending on how much it needs to contract. That way, you can make a muscle contract weakly, as in our feather example, or it can contract strongly, as in our bowling ball example. You'll learn a lot more about action potentials along nerves in a future module, but for now, you need to know that a neuron has to first be stimulated for an action potential to travel along an axon. Motor neurons are stimulated by you being aware of a movement you want to do or automatically conscious of it. For example, if you were to lose your balance and begin to fall, you might not intentionally think that you have to flex your arm muscles so you can move your arm to brace your fall, but your brain is conscious of the need to do that, as opposed to you fainting and falling, unconscious so your muscles will not work. So when you're falling, a conscious part of your brain initiates action potentials in motor neurons. Then those motor neurons stimulate others and others, which stimulate the muscles to contract so that you move your arm. Sometimes a motor neuron receives a small stimulus that's not strong enough for the motor neuron to respond. We call that a subthreshold stimulus. A subthreshold stimulus is a stimulus too small to create an action potential in a neuron. If a motor neuron receives a subthreshold stimulus, no action potential will travel along it, so no muscle contraction occurs. If the stimulus is strong enough, though, it can eventually trigger a single action potential. That's a threshold stimulus. A threshold stimulus is a stimulus strong enough to create one action potential in a neuron. So, one action potential in a single motor neuron moves along its axon and then triggers the action potentials on all the muscle fibers it innervates, so the entire motor unit contracts. That's the all or none law. A single action potential causes a contraction in the entire motor unit. But if you need a stronger contraction in a muscle, you need to have more motor neurons send action potentials to their respective motor units so that more groups of muscle fibers will contract. The greater the stimulus, the greater number of action potentials moving down the axons of the motor neurons. When the stimuli are great like this, we call them submaximal stimuli. Submaximal stimuli are stimuli of increasing strength that create more action potentials along more neurons. Eventually, as the stimulus grows, its strength reaches a point where an action potential occurs in all of the motor neurons of the nerve that go back to the specific skeletal muscle. Then all the muscle fibers in the muscle contract because all the motor units have been activated. This is a maximal stimulus. A maximal stimulus is a stimulus that's strong enough to create action potentials on all motor neurons to a particular muscle. With a maximal stimulus, there can be no stronger muscle contraction because all of the muscle fibers are already contracted. If there's more stimulus, it's called a supramaximal stimulus, but it can do no extra work. All of the motor units have been contracted already. So, summing this up, a muscle is made up of several motor units, consisting of a group of muscle fibers, and the one neuron that innervates them. All the neurons that serve those units within a muscle are wrapped together into a single nerve. So when a stimulus happens, the motor neurons send action potentials down their axons, causing the muscle fibers in that motor unit to contract. Again, that's the all or none law. If the stimulus grows, more action potentials are created on more of the motor neurons in that nerve. That will activate more motor units to contract. We say that a motor unit has been recruited when its muscle fibers have contracted. And again, when a motor unit is recruited, all the muscle fibers in that unit contract completely. If the stimulus is small, only a few motor units within a muscle will be recruited, and the whole muscle will only contract a little bit. If the stimulus is larger, more motor units are recruited, and the entire muscle contracts with a greater force. This is called multiple motor unit summation. Muscle fibers contract according to the all or none law, but depending on how strong the stimulus is, greater or fewer motor units will do the contracting. What an amazing design!